Hello, everyone. Welcome back to today's stream. Today, we're going to be once again going over AWS cloud computing. So, let me share my screen and then we can begin. Okay, so let's get started now. So, welcome to cloud computing. So, the first thing we're going to be talking about is what is cloud computing, and the definition is the on-demand delivery of compute power, database storage, applications, and other IT resources through a cloud services platform via the internet with pay-as-you-go pricing. Amazon Web Services started cloud computing in 2006, where they sold IT infrastructure services to businesses as web services. And cloud computing provides a simple way to access servers, storage, databases, and a broad set of application services over the internet. A cloud services platform like Amazon Web Services or AWS, for example, owns and maintains the network connected hardware required for these services while you provision and you use what you need. It helps to build and run applications, and the cloud can also be used for the deployment and management of applications. They're available to hundreds of thousands of customers across 190 countries, and they give powerful resources at low operational cost. The classically provisioning services is like a Goldilocks problem, so it needs to be perfect. And because of this, with AWS, you are able to elastically scale up and scale down as much as you need to fit your own objectives and business. Okay, let's talk about cloud benefits. So, um, these are a few benefits that we have. So the cloud offers the ability to deliver innovative new features to the market quicker, and it focuses on adding differentiated value. It makes new ideas feasible that were once out of reach, and experimentation becomes fast and it has a lower risk. The cloud can be adjusted to fit any workload. Like we said in the previous slide, you can scale up and down as much as you need to, and it helps businesses to serve their customers globally without the need for expensive, time consuming expansion. And the cloud can also deploy web services using tools and languages such as Chef, Visual Studio, PHP, Java, Python, etc. And it connects to personal infrastructure by a private dedicated connectivity. All right, some more benefits on this slide, like trading capital expense for variable expense, benefiting from massive economies of scale, stop guessing about capacity, increasing speed and agility, and stop spending money running and maintaining data centers, and also going global in minutes. So for trading capital expense for variable expense, you only have to pay for what you consume, and you only have to pay when you're consuming. You can benefit from massive economies of scale. So this means having a lower variable cost and achieving higher economies of scale. And this leads to lower prices in total. And you can also stop guessing about capacity. So you can access as much or as little as needed, and you can scale up or down when necessary, just with a few minutes' notice. And for increasing speed and agility, this reduces the time it takes to make actual resources available, and it causes a large increase in agility because of the cost and the time to experiment being extraordinarily lower. And you can also stop spending money running and maintaining data centers because you can now focus on your own customers. And you can also go global in minutes. So you are able to deploy your application in multiple regions around the world extremely quickly in just a few simple steps. And of course, because of this, this means that you're able to provide lower latency, which is the delay before the transfer of data, and you can also provide a better experience for your customers at a relatively small cost. So now we're going to be talking about TCO, which is the total cost of ownership. So the total cost of ownership reduces the need to invest in large capital decisions, and it provides a pay-as-you-go model that allows you to invest in the capacity you need and use. TCO calculators allow you to estimate the cost and savings, and they also modify assumptions that best meet your personal business needs. The calculator provides directional guidance on possible savings, and the tool itself is built on an underlying calculation model. So it generates a fair assessment of value that a customer may achieve. And it's very important to realize that the TCO calculator results should only be used as an approximation, and they are not going to be 100% accurate. And as we say, every single video that is on these slides, we are going to post them in the description of the live stream once it has ended. So if you'd like to learn more about these certain topics, you can do so. Just keep in mind the videos are a bit lengthy, which is why we don't choose to show it on the slideshow.
All right, great.
All right, now we're on to section 2, which is the types of cloud computing. So there are several different models of cloud computing, and they allow different amounts of control of web services. The three main types that are listed here are infrastructure as a service, or IaaS, platform as a service, or PaaS, and software as a service, or SaaS. So you can see in the image, it has on-site IaaS, PaaS, and SaaS, and we're going to get into more detail on these types. So to start off, we have IaaS. So IaaS contains the basic building blocks for cloud IT, and it typically provides access to networking features, computers, which are virtual or dedicated hardware, and also data storage space. So infrastructure as a service provides you with the highest level of flexibility and management, and it's most similar to existing IT resources, and it also has instant computing infrastructure. Now, for platform as a service or PaaS, so this removes the need for organizations to manage the underlying infrastructure, or usually hardware and operating systems. It allows focus on the deployment and management of applications. It helps business owners be more efficient, and it also disregards human concern over resource procurement, capacity planning, software maintenance, patching, etc. Um, and PaaS is also the combination of hardware and software components together. Now, finally, we're going to be covering software as a service or SaaS. So this provides customers with a completed product that is ran and managed by the service provider. SaaS is usually referred to as end user applications, and there is usually no user concern about service maintenance or how infrastructure is managed. You only really need to know how you are going to use the software. An example of this is web-based email, which is to send and receive email without having to manage feature additions. And again, all of the videos are going to be posted in the description. All right, starting section 3, we're now going to be talking about how to deploy cloud infrastructure easily. So as you can see on this slide, there are four key areas that you need to remember in order to make deploying cloud infrastructure as easy as possible. So number one is highly trusted global infrastructure. Number two is providing broad compatibility with all popular workloads. Number three is having fast and secure private networking. And then number four is having tools to control access to all cloud resources. So number one, highly trusted global infrastructure. So this is designed for high security and availability needs of large enterprises. B, it offers capabilities that restrict unauthorized access or usage without sacrificing flexibility. And C, it has backup for all features. Now, for providing broad compatibility with all popular workloads, so A, it can spin up virtual servers, hard drives, databases, networks, and more. And B, it is easily set up with virtual servers using Linux or Windows. Number three, fast and secure private networking. So A, it provisions a private section of the AWS cloud that you define and you retain control of. It is done with quite simple IP networking. And because of this, cloud environment becomes an extension of your on-premises environment. It uses a standard pipe that encrypts data when it moves from your environment to the cloud, and more data creates dedicated network connection from your existing data centers to AWS. And this gives you predictable network and a performance increase by bypassing the public internet. And now for tools to control access to all cloud resources. Part A, you can create and manage users and integrate with your existing identity systems. B, you can give greater flexibility to rapidly create new apps, lower costs for existing apps, and benefit from the global infrastructure and security of Amazon Web Services. All right, now talking about the cloud. So, cloud based applications are, of course, fully deployed within the cloud itself, and applications in the cloud are created in the cloud too. They can also be migrated from an existing infrastructure to take advantage of benefits, and cloud based applications can be built on low level infrastructure. You can also use higher services that provide detachment from management, architecting, and also scaling goals. Now we're going to be talking about hybrids. So this is a way to connect infrastructure and the applications. It connects cloud-based resources and existing resources as well. A common method of hybrid deployment is to extend and grow an organization's infrastructure into the cloud while also connecting the cloud resources to the internal system. You can run applications in both cloud and on-premise, and you can also access AWS whenever you need to. So you can see here we have a few hybrid cloud storage challenges in the image, and this compares the on-premises to the in-cloud. So on-premises, you can say that you want to run your existing applications without change. And when using in cloud, you could say that you would want to leverage the full infinite scale of the cloud. On-premises, you can say I need local access to data. And in cloud, you can say while accessing the power of cloud compute and analytics. In on-premises, you can say compliance requires that you integrate with enterprise security and management tools. And in cloud, you could say that you want to manage and monitor from a single pane of glass. On premises, you can say you need reliable, easy connectivity into the cloud. And in cloud, you can say that you need this even when your data is in many different locations at once. All right, now for on-premise. So this is referred to as the private cloud, and it takes advantage of virtualization and resource management tools. On-premises deployment leads to the inability to receive cloud computing benefits, and it's used to provide dedicated resources. Typically, it's the same as previous IT infrastructure, and it uses applications management and virtualization technologies in order to increase resource usage. And this is another video on cloud versus hybrid versus on-premise, which is going to be in the description. Right now we're on to section 4, in which we are going to be talking about AWS security. So AWS infrastructure installs safeguards to protect privacy, and this data is kept in very highly secure data centers. It manages dozens of compliance programs, and segments of compliance have already been completed. AWS security, so they have the high security without user managing their own facility. They are able to save money at the same time, and you can also scale security with your AWS cloud usage. And the security is maintained regardless of the cloud size you choose. This is a video on AWS security. Now we're going to be talking about AWS Analytics Services. So this is a set of services that handle every step of the analytics process. These services are powerful, flexible, and yet simple to use, which thus enables organizations to put their unorganized data to work efficiently. Example services include Elasticsearch, Amazon Kinesis, Amazon Redshift, and Amazon Athena. So Elasticsearch is an open source search and analytics engine which is used to log analytics, real-time application monitoring, and also user click analytics. Amazon Kinesis enables you to absorb, buffer, and process streaming data to find insights promptly. Amazon Redshift can ask questions and combine exabytes of organized and disorganized data across your data warehouse, operational database, and data lake, which is a centralized repository that allows you to store all of your structured and unstructured data at any scale using a language called SQL or standard query language. And finally, Amazon Athena is an interactive question service that makes it simple to analyze data in Amazon Edge 3 using a standard query language or SQL. Now to talk about AWS compute services. So AWS offers multiple services that can deploy, run, and also scale applications as virtual servers, containers, or code. Examples of this include Amazon EC2, which obtains service quickly and inexpensively, Amazon Lightsail, which creates a virtual private server or VPS on AWS, Amazon Elastic Container Service, which runs in Docker containers, and these containers contain software that are in standardized units known as containers. And containers package everything a software needs to run, including libraries, system tools, code, and also runtime. And AWS database services. So these are necessary databases for applications such as managed relational, non-relational, data warehouse, in-memory data store, and graph databases. Amazon DynamoDB is a fast and flexible database service for any workload. And like most things in AWS, you only pay for what you utilize. The key value database that delivers a nearly instantaneous single digit performance at any scale is this one. It's built to handle internet application. It's a fully managed service and handles more than 1 trillion requests per section. Now for Amazon Relational Database Services or Service, which is RDS. It's a relational database service with 6 well-known database engines, and it can be set up, operated, and scaled in a few steps. And another video that's going to be posted in the description in the corner. All right, now for section 5, which is the AWS developer tools. So these contain codes and automatically create, evaluate, and deploy application. It's a set of services that quickly and carefully deliver software. They service, store, and hold control of your application source code. They're used for constant integration, continuous delivery, infrastructure as a code, and also monitoring. AWS Code Pipeline, they can create an end-to-end software release workflow using services, and they have continuous delivery since service that automates the release of pipelines in order to have fast and reliable application as well as infrastructure updates. They can effectively and efficiently deliver features and updates. And for the AWS Cloud Development Kit, it is an open software development structure to define your cloud application resources using known programming languages. And they supply cloud applications that can be a challenging process, which require you to perform the following, which is manual actions, writing custom scripts, maintaining templates, or learning domain specific languages. And the AWS Cloud Development Kit utilizes familiarity and expressive power of programming languages in order to model your applications. And now for AWS Cloud Deploy, Code Deploy, it's a tool that installs applications and updates servers. It lowers the workload on developers and quickens the release of new products and features. Code Deploy makes it simple for users to rapidly release new features, help dodge downtime during application deployment, and deal with the complexity of updating applications. And positives of this include automated deployments, minimized downtime, centralized control, and also being easy to adopt. Now to talk about AWS management tools. So these allow you to provision, monitor, and set forth your cloud environment. You can also maintain stable control without restricting your development speed. AWS CloudWatch is a service which was built for developers, system operators, site reliability engineers, and IT managers. CloudWatch provides information and insights to monitor your applications, understand and respond to system-wide performance changes, optimize resource utilization, and get an allied view of operational health. They gather monitoring and operational data in the form of logs, metrics, and events, providing you with a linked view of AWS resources, applications, and services that run on AWS, and also on-premise servers. AWS CloudFormation provides a common language to supply important assets in the cloud, and provisions can be automated to be sent over and over again, and they model infrastructure using a simple text file. And also for the AWS Systems Manager, they allow full control of the structure of AWS. They automate tasks needed for smooth operations. They help guarantee security and compliance, and they also can detect problems quickly. Now, talking about AWS networking and content delivery services. So, this allows you to isolate your cloud infrastructure, scale request handling capacity, and connect physical network to private virtual network. The networking products would work together to meet the requirements. For elastic load balancing, it coordinates with Amazon Virtual Private Cloud or VPC to give networking and security features, and it distributes application and traffic among different services. It also handles traffic in one or more availability zones or data centers, and it improves scalability or adjustability of your applications. For storage services, these are reliable, secure, and adjustable locations for your data. AWS offers a wide variety of cloud storage services to support both your application and archival compliance requirements. Archival requirements are the dates when things can be archived or stored away and hard to get back. One can choose from different options to build the base of your cloud storage management solution. And in AWS, the different types of storage services include object storage, file storage, block storage, backup, data transfer, and edge computing and storage. And this is a video on an introduction to AWS services. All right, and that will be all for um, AWS Cloud Computing. Thank you all for attending today's session, and we will see you in the next session. Thank you for watching.